And hello, welcome for the relearning for the secant and chord properties of our circle unit that we had. Please make sure that you put your date that you are looking at this at the top, as well as your name and your period. If you could put that on here, even though I didn't leave a spot for that. Again, if you're looking at this and you don't have a paper, the paper is located in the back of room 1029 in the blue compartment way at the bottom, because we're at the end of our standards for the year. Okay, so make sure that you grab the U-tries. If you are looking at this video and you're looking at it on, I'll make sure that you copy the U-tries down so that you can show me those so that we can do the reassessments after that. Okay, so now we're looking at some basic definitions and we're looking at a chord. We need to know these definitions as a chord. A chord is a line that has a pen is dying, so I'll use this one. Chord is a line that goes across here at the top. It's a line segment with the end points on the circle. So it can be on the edge, it can be way up here. It can also be right through the center. If it's right through the center, we call that a special name. We call that diameter. And but we can have any chord property. A secant, on the other hand, is a line that goes all the way through. So we have a line, not a line segment, a line that cuts the circle in 2 points. Or we could say at 2 points. So right here we have a line, a secant. And inside a secant, you can see we have a chord, but we're looking at the whole process where it cuts through and it keeps on going. It's a line that goes in each direction. A lot of times we don't show it with the arrows, but yet nonetheless, there they are. A tangent. A tangent is again, a line that touches the circle in exactly 1 point. So it only touches right here. It looks like it's more than that, but really it isn't. It can be anywhere. It can be down along here, just as long as it touches the circle only at 1 point. Okay, so there's 2 parts of this. We're looking at part 1 where we're going to find the arc or the angle. So there's 2 parts to the standard. The first part is finding the arc or the angle. So when we're looking at here, we have 2 secants. I drew a circle on here already for us, so we're going to just put our secants in here, and the secants cross. They cross right here. Put our arrows down here, and it creates 2 arcs. It cuts the circle in 2 points. That's a secant. But this part right in the middle, these 2 little arcs are the ones that we're interested in here. These 2 arcs. Here's one, and then here's the other. So we're looking at where they cross directly through here. We're going to call this one back here. We're going to call that the far arc, because it's far away from our angle. This arc measure right here is the one that's closest to our angle, and this, of course, is our angle. So we're going to use these terms in here. So we can coordinate these all together, and there's lots of reasons why. And if you need to know why, you can go back into Hapara and look at the presentations. But when we're looking at this, we have the angle is equal to the far measure minus the close divided by 2. So this works out that this value in degrees minus this value in degrees equals our angle value, equals our angles. We can figure out going back and forth. Maybe we want the one that's closest. We use the same formula. If we want one far away, we say the same thing. And we use this formula to be able to figure out which one is which. Now, we have our subtraction sign, and then we need to associate it with the vertex of our angle, which is outside of our circle. You can either associate it with 2 secants, or you can associate it with the vertex, which is outside of our circle. If we have 2 chords, Doesn't matter what the chords are, it could be anywhere. We can cut even directly in the center of our circle, although it's not helpful. We're looking at this and we're looking at this as our angle. So this right here is our angle, right here, this one. And that has two arc measures that are associated with this one right here and this one right here. So you can say back and front, you can say near and far, but this is our angle that we're looking at. So this is our arc. So it cuts right through here, and this is our pizza slice we're interested in. So the way that this one worked is the way we talked about it in class was it's 2 times the angle measure, and these are all in measures, we're not talking about arc lengths, equals the sum of the arcs. Another way that we can think about this is if you want to think about it as your far and your near, if this is our angle, this one would be the farthest away, and this one would be close. You would say the angle equals the far plus the close and divide by 2. Both are exactly the same that when we're putting things together. I prefer this one right here. It's a little cleaner for me, but you can do this one as well if that's helpful to you. Okay, so let's take a look at what some properties are here. Now again, we're just on the part 1. We're going to get to the segment part very soon, but right now this is one we're looking at in part 1. So we're looking at in here, we can see that we have two chords right here, no secants, and our angle vertex, whatever we're looking at, which is right here, that's the angle we're interested in. We're looking at this arcs, these two arcs. This angle is inside the circle. So when it's inside the circle, you add the arcs, and when it's outside of the circle, you subtract. So we're going to do our thing. 2 times the angle equals the sum of the arcs. The sum of the arcs. So let's see, our angle is unknown. So we're going to do 2x. That's where we have in here. We're just an unknown. We're going to put that as x. We're going to equals 116. That's the measure of this arc right here, plus a 110. Now it becomes quite easy. 2x equals that's 226. 226, and we're going to divide both of those by 2. 226 divided by 2, 2 into 2, 226, 113, x equals 103, or excuse me, 113 degrees, 113 degrees. So we just add the two back and forth, what we have in here. A vertex is in the center, or is close to the center. There, we can see if this is 113, this is 110. If it were just maybe scooted a little bit this way, it would be a central angle, but it's not quite. So it's just a vertex of our angle is inside. This one's a little bit easier to look at because we can see that our vertex of the angle that we're interested in, which is right here, this is our angle we're interested in. This angle is got a vertex in the center, but it's nowhere near the center of our circle. It's the vertex is in the center, in the circle, but not the center. Same thing, 2 times x, that's the measurement that we're looking for, we don't know, equals 83 plus 21. So this is one we're looking at, this is the other, plus 21. 2x equals 104. Divide both sides by 2. X equals 52. And of course, we're looking at measures right here. We have degrees, we have degrees, we have degrees. Our answer is going to be in degrees as well. Looking at it in here, we're given the angle measurement, but we're looking for this, if you will, close arc. So this measure right here is for our angle, which is 50, and then the two arcs that are associated with it are the one that's farthest away, which is right over here, and this one over here, which is really close. So we're going to do the same thing. 2 times our angle measure, which is 50. So nice how that works. And then we're going to have 75 plus x, 75 plus x. Vertex in the circle, add. Vertex out of the circle, subtract. So we have 100 equals 75 plus x. And we can quite clearly see that x is equal to 25 degrees. 25 plus 75 equals our 100. We have another example right over here. We're given the angle measurement. It's right here. We're looking at the arc that's in front of it, the one that's in back, or the one that is farthest away, the one that's closest, however you want to do that. 2 times 122 equals 114 plus x. 122 is 244 equals 114 plus x. Subtract 114 from both sides. X equals 130 degrees. 130 degrees. Quite clean in how we would do that. Now the second part, the number 10 and number 11, are problems that we deal with the vertex outside of the angle. So we're looking at this as the angle equals the far minus the close divided by 2. So our angle is unknown. So we're just going to call that x just to make life easy. We could call it angle. We could call it r if we wish, because that's the vertex right here is r. Our farthest number is 150. We're going to subtract 40 from here. So we have our vertex is out. So we're going to subtract this arc, which is what our angle cuts right here, our intercepted arc, and this is the back side of it. We're going to divide that by 2. X equals 110 divided by 2, which gives us 55 degrees. 55 degrees. This one is the same, only we're given the angle measurements. So we're saying the angle is the far minus the close. So we're going to put our angle in here. 62 equals 141 minus x. We don't know what that is. We're going to divide that by 2. Something, 141 minus something divided by 2 is going to give us 62. That's a little tricky to think about. Maybe we can do guess and check if you want to. You could put in different values in here, maybe going in here and doing 20, maybe 25, figure out if you're close. Or you can multiply and get that 2 out of the denominator. So we're going to multiply both sides by 2. So that 2 divided by 2 is 1. So that basically cancels out. 2 times 62 gives us 124 equals 141 minus x. Now remember, minus x, we have a coefficient of 1 in front of there. We just have that ghost 1 that we're putting in here. We're going to subtract 141 from both sides. And we're left with a negative 17 equals a negative 1x. Now maybe you're very clever and you can see the negative and a negative means that the x has to be a 17. But if you can't see it, divide both sides by negative 1. Then we have x equals 17 degrees. So 141 minus 17 divided by 2 will give us our 62 degrees. So quite simply, those are the first step that we have of our part 1, where we're doing our angle measurements or our arc measurements. Part 2 is where we're going to have line segments. So line segments is our part 2. So we have a formula for looking at 2 secants. So once again, we have our circle. We have 2 secants that we're looking at in here. And we're going to be looking at these and putting them together to figure out our formula. So for the sake of time, I'm going to give you it. It's the outside times the whole equals the outside times the whole. Okay, so what does this all mean? So we have this line value right here, right here. This is our outside value. That's this outside. So the length of this line is the outside. The whole is the entire thing. And we're going to this section right here where we can actually count this whole thing right here. So it's the outside and the inside added together. If you're looking at this for the second part, again, this is our outside right here. And then we're looking at, again, the whole. This is this hole right here. And then we're looking at this is our hole. From here all the way to our vertex. So we add those both together. So that's our hole. Oh, my pen isn't working so well. I think you get the point, though, what we're looking at. So the orange is the outside section, the yellow is the outside section, and then we're putting them together. So let's take a look at what it would look like if we had two chords. So again, we have in here two chords. We have our circle. We're going to just draw two chords in here. And quite simply, we can put these together that this is our orange, and this is our yellow. So we're going to call one A and one B. So we're going to take A times B, whatever those length is. A is orange, B is yellow. Okay, so looking at these, A is orange, B is yellow, and we're going to multiply those two values. Now we're not talking about arc lengths or anything like that. We are talking about a length of a line, So these are going to have answers of centimeters, meters, inches, whatever we need to do. This is going to be equal to, and we're going to have C and D. So we're going to call this one C and this one D. So put our colors in here, seems to be handy. Using the D is the green. That's the length of the line. That's our D that we're looking at. And then we'll use our other green marker to tell us our C right here. And that's this part right here. So this is the skinny green. The skinny green. So the skinny green times the fat green equals the orange times the red. The last one we're going to be looking at in here is we're going to be looking at the tangent, and we're going to look at the tangent and the secant. So this means that we have our tangent line, which is what we talked about earlier, and we're really interested in that point. It can go on forever here, but we're really interested in this value here and where it crosses our circle. So this little bit right here is the part we're interested in. So we're going to take that green part, we'll call that A squared. And then we're going to use our formula that we had before. We have our outside right here times our whole length, the whole thing. So this is going to be, we'll call this B and C equals B times B plus C. So the whole length. So we can call this as the outside times the whole equals the A squared. It seems like a knot, but there's basically three main concepts. And that's what we're looking at, these three main concepts for the segment lines. So if you notice in number 15, there aren't any values in here. No values that we're looking at. We're putting in there's no units as far as anything with degrees. So we're looking at line segments. So in here, we're saying that we have our vertex outside of our circle. So it's our outside times our whole equals our outside times our whole. Okay, so let's do this how we're putting this together. We're saying 6 times the entire length, which is 6 plus 9. The entire length equals 5 times the entire length. Now this is our unknown. We don't know what that is. If it were number, we could just say that add 5 to that number. But we don't know what that number is, so we're just going to say that 5 plus whatever that number is. 5 plus whatever that number is. And so in here, we're going to put this together. 6, and then 6 plus 9 is 15 equals, and then we're going to use our distribution property. Please don't get mixed up on saying that 5 plus x is 5x. It isn't. So we have 5 times 5 plus 5 times x. 6 times 15 is our 90 equals 25 plus 5x. And now we can see our problem. It's our normal problems that we're looking at for algebra. 65 equals 5x. Divide both sides by 5. And x equals 13 units. Not degrees, units time, not degrees. So this is a different one that we're putting together. It gives us, it asks us for the full length. This is a z that we're looking at in here. So we don't have to worry about what's on the inside here. We don't have to worry about that. We can say in here that 3 times the entire length, which is our z, is equal to 4 times 4 plus 8. 4 times 4 plus 8. So 3z equals 4 times 12. And then we have 3z is equal to 36. Divide both sides by 3. Z equals 16. No, z equals 9. Oh, sorry about that. That is 48. 4 times 12 is 48. 48 divided by 3, and there's our 16. So this whole thing is 16. Now, if we wanted this part right in here, we could easily say that this is 3, then this must be 13. That's where the 13 was coming from. So the whole thing is 16 units. All right. Now, here we're looking at this. We're looking at where it touches the circle at 1 point. And we could continue on, but we can see our tangent here. So our tangent is that this little tangent is squared. We can think about it as, since it only touches at 1, we have to multiply it by itself. The outside is 7 times 7 plus 21. 7 plus 21. So 7 on the outside plus the entire thing. X squared equals 7 times 28. X squared equals 196. Take the square root of both sides. X equals 14 units. 14 units. We have just a couple more and then we'll be all done, and you can work on your U tries. These might become clear to you right away. So we have a 6 and a 6 and a 9 and an x. There, the vertex is inside the circle. 9x equals 6 times 6. 9x equals 36. Divide both sides by 9. We can see that x equals 4 units. 4 units. And this one's also quite nice. 8 times x equals 6 times 4, which is 24. Divide both sides by 8. X equals 3 units. So that's it. There's 2 parts. There's the arc length, and then there's the arc measure and the angles, as well as the length of the segments. So you have to remember all parts. Here's the U try number 20. Here's the back side. 21, 22, 23, and that's it. Make sure you get all of these U tries in here if you're looking at them at home on your own. Thank you.